In this video, I'll talk about the rotational and translational kinetic energy of a helicopter. So we have a helicopter with the 4 blades. The length of each blade is 5 meter and the mass of each blade is 60 kilogram. The total mass of the helicopter is 1200 kilogram. Now we need to find out what is the rotational kinetic energy of the blade. If they rotate about 350 revolution per minute, and then if the helicopter is flying or moving at 80 miles per hour, what is its translational kinetic energy? And what should be the total kinetic energy? Which one is greater, the translational and kinetic energy? We will be calculating everything in this problem. So let's start with this one. So the mass of each blade is given, which is 60 kilogram. The length of each blade is 5 meter. And the blade is revolving or rotating about 350 revolution per minute. And if you need to change revolution per minute to radian per second, you have to multiply by 5/30. And it's calculated here. 1 revolution per minute is 1 revolution per minute equals to 2 pi, because 1 revolution corresponds to 2 pi. If anything moves 1 complete circle, then the total angle will be 2 pi. So that's what it means. And 1 minute is equal to 60 seconds. So 2/60, now it will be pi/30. So in order to change from revolution per minute to radian per second, you have to multiply by pi/30. And if you solve it, you'll get 36.65 radian per second. The mass of the helicopter, this including the blades as well, is 1200 kilogram. And the translational speed is given 80 kilometer per hour. 80 kilometer per hour. And we need to change 80 kilometer per hour to meter per second. So the 1 kilometer corresponds to 1000 meter and 1 hour corresponds to 3600 seconds. So if you simply do the math, you'll get 22.22 meter per second. That means in 1 second, it moves about 22.22 meter. So first thing we'll do is calculate the moment of inertia of each blade. The blade can be assumed as a single rod, as a rod here. And we have 4 blades here. So the total moment of inertia would be 4 times the moment of inertia of each blade. And remember, it is rotating about this axis here, this axis, or in other words, it is rotating about this axis. All the blades are rotating about this axis. So it is not through the center of mass, it is somewhere at the end. It is rotating about the end. So the moment of inertia of a blade or a rod about one end is given by ml²/3, where this is the mass of the blade, B stands for the blade, L is the length of the blade, and then you'll get another factor 3 here. Okay, and this is already calculated, so you have to watch my other videos to see how to calculate the moment of inertia of a rod about the one end. So 4, now let's plug in all the values. The mass of each blade is 60, the length of the blade is 5 and 3. If you solve it, you'll get 2000 kilogram meter square meter. This is the moment of inertia of the total blades, of all the 4 blades about this axis of rotation. So now let's calculate the rotational kinetic energy. The formula for calculating the kinetic energy in rotational dynamics is half I omega square. And I is the moment of inertia and omega is the angular speed. So we have the moment of inertia I we just calculated, which is 2000 kilogram. Omega is the angular speed. We just calculated this one too, omega, which is 36.65, and if we solve it, this is the energy you will get. This is the rotational kinetic energy. Let me ask you a question now. Here we have taken the moment of inertia of the blade, the entire blade here. We did not take the masses of the other masses into account, or we did not calculate the moment of inertia of this helicopter. We just calculated the moment of inertia of each blade. Why? And you can see here the answer is only the blades is rotating. This one is just moving. This mass is only moving in one direction, or it has only the linear motion. The only rotational motion has the blades. The blades are the only thing that is rotating. So we just took the when we calculated the rotational kinetic energy, we only took the moment of inertia of the blades into account, because only the blades are rotating or revolving. Now let's calculate the translational kinetic energy. So when the helicopter is moving, the entire system is also moving here with a certain velocity. Even the blades are moving along in the direction of the motion. So in order to calculate the translational kinetic energy, the formula is half mv squared, where m is the mass, total mass of the helicopter, v is the linear velocity. So everything is given. The mass is 1200 kilogram. The velocity we just have calculated is 22.22. So if we solve it, this is the kinetic energy of the translational kinetic energy of the helicopter. This is for the entire helicopter, and this is only for the blades. So the total kinetic energy of the helicopter should not be the blade, but it should be the helicopter. Including blades. Is given by this formula as the kinetic energy, a scalar quantity. We're simply adding these two numbers now. Kr stands for the rotational and Kt stands for the translational kinetic energy. So this is now the total kinetic energy of the helicopter including blades. So now let's compare the translational kinetic energy to rotational kinetic energy. So I'm just finding out the ratio of translational kinetic energy to the rotational over translational. So if we just plug in all the numbers, what you get is 4.53. What does 4.53 means? This means the rotational kinetic energy is 4.5 times greater than the translational kinetic energy. Okay. So the blade, in fact, has more kinetic energy than the translational kinetic energy of the entire helicopter. Okay, let me repeat one more time. The blade has more translational kinetic energy than the entire translational kinetic energy of the helicopter. So this is it from this lecture. Again, if you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.